Hello everyone, I am Liangyang Ouyang from the University of Tokyo. This is the video for our ECCV 2024 paper named ActionVOS, Actions as Prompts for Video Object Segmentation. The background of our research is based on the task of referring video object segmentation, as known as RVOS tasks. So RVOS tasks aims at segmenting target objects using natural language expressions. However, existing RVOS benchmarks primarily rely on static attributes, such as object names and colors, to describe the target objects. In complex scenarios where redundant instances coexist or object state is changing, such static attributes fail to identify target objects. For example, in the first video, there are many carrots and many balls in this scene. If we use carrot or ball to describe the target objects, the model could not identify what is the target. In the second video, the person's nail is painted from pink to blue. So both nail or pink nail or blue nail could not identify the very nail that's being painted in the video. To solve the challenges, we use human actions as additional prompts for RVOS task. This is because human actions precisely describe the target active object. For example, when using put carrot in bowl to describe the video, the target carrot and bowl are identified. When using paint nail, the very nail being painted is precisely described, even though we don't know what color the nail is. Based on the key idea of human actions as prompts, we propose our new task setting for RVOS named ActionVOS. Comparing to common RVOS tasks, ActionVOS takes an additional action prompt input and segments only active objects that corresponded to the action prompt input. We also proposed a method for this ActionVOS task setting. This is the overview of our proposed method. Our goal is to train an ActionVOS model. An ActionVOS model can be viewed as an RVOS model plus an extra classification hand. This class hand is used to classify if the input object name is active in the input action prompt. However, existing annotations do not have ground truth labels of if the object is active in this action. To solve this challenge, we propose an action-aware labeling module to get pseudo-active object class labels by using existing annotations. We use two rules to identify active objects. The first one is the objects whose name is mentioned in the action prompt, we view they are active objects. For example, carrot is mentioned in the action of cut carrot. The second rule is the objects whose mask is intersect with hand object binding boxes, which means it would be near to the human's hand and may be manipulated by the human's hand, are pseudo-active objects. For example, knife and cutting board in this example. The pseudo-labeling module brings many false positives because sometimes the object in hand or near hand is not active. Also, some redundant instances, they are mentioned in the action prompt, but not really used in the action. So in addition, we propose an action-guided focal loss to adjust the pixel-wise weights and reduce the impact of false positives. For example, there are 3 pens in the video of put down pen, and the pen that is in the person's hand receive the highest loss weight, which is the red color area. Because this pen is both its name mentioned in the action prompt and held in the hand. After getting pseudo-labels and the loss weights, we use them to train the ActionVOS model. Note that both the action-aware labeling module and our weight generation function do not have trainable parameters. So they are training-free lines, which means that any RVOS models are compatible with our proposed method. Here are the experiment readouts of ActionVOS on wider datasets. And by adding action prompts, ActionVOS models get +5 to 10 PMIMOU and GIOU, and get 34% lower NMIOU comparing to RVOS, which means we have less missegmentation on inactive objects. The left side is the readouts on VOST and VSCOS datasets, where ActionVOS have much higher MIOU for state-changed objects. And the right side are ActionVOS comparing with some baseline methods, and we have 10% higher PMIOU comparing to hand object segmentation models, and we have 16% lower NMIMOU than common RVOS methods. Here are some visualizations that comparing to models that do not take action prompt inputs. We can see that action prompt significantly reduce the missegmentation of inactive objects. Here is another visualization of different action prompts in the same scene. We use the same input video objects names, but different action prompts. And our model can automatically segment only active objects that's corresponding to the very input action or prompt. This is the conclusion of our ActionVOS paper. We propose an action-aware setting for RVOS task named ActionVOS. We propose a method working under this new setting. And our experiment showed that ActionVOS significantly reduce the missegmentation of inactive objects and enhance the segmentation of state-changed objects. For the paper, code, and more details of our work, please check the QR code on this page. Thank you for watching this video, and thank you for your interest of our ActionVOS work.